Today's aim is we're going to write and graph equations of lines that are in slope-intercept form and graph and write lines for vertical and horizontal. So this is the newest part of our lesson today, is looking at these special case lines. Looking at the first special case line, it is x is equal to 4. All right, so this is a line. It doesn't look like a line because it doesn't have two variables. It doesn't have a y and an x. However, it can be represented as a line. So when we see x is equal to 4, that's telling me I want to know all points on the coordinate grid where x is equal to 4. And so in this particular case, this is 0, 4. I could do 1, 4. I could do 2, 4, 3, 4, 5, 4, so on. Or I could do negative 4, negative 1, 4, negative 2, 4. So what we can see here is that these points represent a vertical line. Okay? So this is what x is equal to 4 looks like when it's graphed. It's this nice vertical line that shows us all of the different places where x would be equal to 4. It represents all of the solutions, all of the pairs where x is equal to 4. Axel. Four. X is equal to 4. I did not. So when we want to talk about this, we also want to talk about the slope of this. This is a very important thing to know. When I look at the slope of this, I can pick any 2 points. It doesn't really matter. We're going to get the same value. So my change in y from one point to the next, change in y is 1 over my change in x. There is no change in x. Change in x is 0. Now, this tells us something very special about the slope because we have a division of 0 going way back to unit 1. What is the result of a division of 0?
0.
Crystal? Undefined. So the slope of this line is undefined. And the way that you can remember that is just remembering that anything divided by 0 is undefined. And if you look over here at the graph, we have a change of x is 0. That's why we get that division of 0 in our slope. All right? And so what does it look like? Well, it looks like a vertical line. It's vertical. All right? Our next special case line is this one, y equals negative 8. So we're looking for all the coordinate pairs where y is equal to negative 8. So I have 0, negative 8, 1, negative 8, 2, negative 8, 3, negative 8, 4, negative 8, or negative 1, negative 8, negative 2, negative 8, negative 3, negative 8, and so on. We can see all of these points are representative of all of our values, and they would just keep going on in this line. So this is going to be our graph of y equals negative 8. So it's a special case as well. What does it look like? How would we describe this line? How would we describe this line? Axel?
Horizontal.
Yeah, this is horizontal. And if we start thinking about the slope of this line, if I pick any 2 points, my change in y, well, there is no change in y. It doesn't go up or down at all, so my change in y is 0. And my change in x might be something like 1, it might be 3, it doesn't really matter, because 0 divided by anything is 0. So the slope of this line is 0. So we need to make sure that we understand the difference between a slope of 0 and a slope of undefined. All right, so undefined is when we get that division of 0 because change in x is 0. And a slope of 0 is when we get that change in y is 0. So we're dividing 0 by something. So this should go way back to unit 1. All right, so those are our special cases. X is equal to something, y is equal to something. So moving on to the review portion of our lesson today, we're going to be looking at writing some equations or graphing some lines And so when we're ready to write an equation, we know how to write equations in this slope-intercept form, y equals mx plus b. So the two things that we have to fill in here are the m and the b. What does the m stand for?
Y-intercept.
What does the m stand for?
Slope.
That's the slope. So that's going to be looking for the change in y over the change in x. And b is equal to our y-intercept. So we're going to have to be looking for where our value hits the y-intercept. So I always start with the y-intercept because it's easier, especially on graphs. So I'm looking for my y-intercept. Where does my line intercept my y-axis? Where does my line intercept my y-axis? Is it here?
At the 1, 2, 3, 4, 5, 6.
So here, count it out for us. He says it's right up here, and this is at 0, 6, so that tells me that my b is going to be 6, so I can fill that in. Now I just need to deal with the slope. Now I just need to deal with the slope. And I'm looking at these 2 points here. And I'm just figuring out what my change is. So my change in y, I had to go down, so that's a change in y of -2. And my change in x, from there I go forward, +1. All right, so we know that my slope is going to be -2 over 1. That simplifies just to -2. That's the same thing. So I can now write my equation. Y is equal to -2x plus 6. Pretty easy. Now, if we're not given the graph and we're only given the t-chart over here, we can pretty much do the same thing. We still need to know y equals mx plus b. It's just our process of how we find m and b is a little bit different. So when I'm looking for my y-intercept, I'm looking for when x is equal to what? If I'm looking for my y-intercept, I'm looking for when my x is equal to what? Yeah, thank you for showing me with your hands. We're looking for when x is equal to 0. All right, so just as a reminder, as we look over here at this other graph, this is where x is equal to 0, right down the middle. That's why that's our y-intercept. So over here, we have 0, 4, so that tells me that my y-intercept is +4. And if I need to find the slope, I don't actually need a whole bunch of points to find the slope. I can find my change in y from here to here, my change in x from here to here, and that should be enough, because between any 2 points, the slope should be the same. So that's why I only really need these 2 points. So my change in y here, I go from 4 to 0. I'm going down 4, so that means I need to make sure that that's a -4. And from 0 to 5, that's going up, so that's a +5. So when I come and look at my slope as my change in y over my change in x, I can see that my x, or my y changed, -4. And my x changed this +5. So what I see is I can't simplify that any further, so I get my slope is equal to -4 over 5. So I can finish writing my equation. Y is equal to -4/5 x plus 4. Questions are here?
You know where it said y equals mx plus b?
Yep.
How do you know if it's addition or subtraction?
How do we know if it's addition or subtraction? All right. So Zahir is asking about the center of this. How do I know if this is going to be addition or subtraction? Danilo. Yeah, it depends on what our y-intercept is. If our y-intercept is negative, we could switch that to be a subtraction. But if it's positive, we're always going to end up with this positive value in the plus. We'll see another example of that here in a second. All right. Looking over here. This is a little bit different. I'm asking you to quickly create an XY chart given this value. So the first thing we want to do is I would identify my first starting point, which is always going to be my y-intercept. Now I don't look
it doesn't look like I have a y-intercept here. So what do I need to put onto this equation to make sure that it has a y-intercept? What can I add to this equation without changing the value of the equation to give me a y-intercept? PK, what do you think? A b, particularly we need a value here. 0, absolutely. So that tells me that my y-intercept is 0. So what is my x value for my y-intercept? What is the x value for my y-intercept? It's always the same. 0. Which means the y value for my y-intercept in this case is, it's also 0. So I have these 2 points. I have my slope over here, which is equal to 1/3. So my m is equal to 1/3, which is equal to my change in y over my change in x. So my change in y is going to be a bunch of plus 1s as I'm filling out my t-chart. And my change in y, or my change in x's, is going to be a bunch of plus 3s. So 0 plus 3 is 3, 3 plus 3 is 6, 0 plus 1 is 1, 1 plus 1 is 2. And if I want to take a point that goes backwards, that means I need to go backwards 1 to -1 and backwards 3 to -3. All right. Now over here, I want to graph this equation, y equals -2/3 x plus 2. Whether I'm graphing it or putting it in a t-chart, I always want to start with the same point, and that's the easy one. That's the y-intercept. Somebody with a raised hand, tell me where I would plot the y-intercept. At what coordinate pair would I plot the y-intercept? Where would I plot the y-intercept? Jalen. So right here in the middle. Where in this middle though? Where in this middle? Up 2. Looking at our y-intercept is 2, so 0, 2. And then I want to follow my slope. So my slope is m is equal to -2/3. So my change in y needs to be a -2, and my change in x needs to be a +3. So I have a negative change in y, so I'm going down 2, and a positive change in x, so forward 2. A negative change in y, 2, forward 3. So one thing that we can double check is we have a negatively sloped line, clearly, and I am graphing a negatively sloped line. And obviously you guys are going to use a straight edge and get much closer to through those points. And just a couple more examples really quickly to write the equation. I think that's the thing we struggled with a little bit more. So when I look at this one, I'm going to find my changes in y's and changes in x. This is a decrease of 2. This is a decrease of 4. This is a decrease of... Oh, no, sorry, that's an increase of 8. This would be an increase of 6. This would be a decrease of 3. And this would be an increase of 6. So what I see is a bunch of different values here, but if this is indeed a line, remember that all of those ratios should be the same. So I'm going to check out those ratios, change in y over change in x. So this is going to be -2/6, which is the same thing as -1/3. And this is going to give me -4/3, which would be the same thing as +4/3. So what that tells me here is what? What does that tell me about this quote-unquote line? If it doesn't have the same rate throughout, this goes back to day 1 of this unit. What does that tell me about this quote-unquote line? Yes, sir. negative 3 and the 5 be a negative 5. Oh, so this is what I hear him saying. I hear him saying that this is 8 over 6, 4 over 3. So he's saying that it looks like something is wrong with that first point. So actually the way this is not a line. The rate is not the same all the way throughout, so this is not a line. Now he suggested that the way you could make it a line is if you change this to a negative 5, in which case you would get an increase of 8 and an increase of 6, which would be absolutely right. However, I want you to be checking all of the points, and I want you to be able to tell me that this, the way it is, this the way it is not a line. This is not a line because it has different slopes throughout. All right. And the last one. All right, so we have here, I need to get this to y equals mx plus b. What is my b here? Isabel, what's my b? Where does it intersect my y-axis? At negative 2. So over here at negative 2. So my b is going to be negative 2. So plus negative 2. And now I need to find my slope. So I'm going to pick any 2 points. They've picked out 2 points for me. So I see that I'm going up 4. So that's a positive 4. And I'm going forward 2, so that's a positive 2. So my change in y over my change in x is equal to positive 4 over positive 2, which simplifies to what? 4 over 2 simplifies to what, Andrea? Positive 4 over positive 2. Which is equal to just simply 2. So when I write my equation, I'm going to write this as y equals 2x plus negative 2. Now going back to Zahir's question earlier when he asked about how do I know if it's a plus or a minus, this is one that we could change back to a subtraction. I could leave change switch this back to a subtraction. And I don't really care which way you give me your answer when you give me your answer, but you do have to recognize that they are the same. Okay? So remember when we have that negative, it's really like it was leave change switch, so you could change it back to a subtraction if you wanted to. All right? Just realize that those are both the same. I think you guys know that.